We're going to continue looking at the quadratic formula, when to use it, and why we can use it. So the quadratic formula, again, it's not necessary to memorize it in New York State. It's part of the reference sheet that you get whenever you take the exam, whether it's in June, August, or January. The quadratic formula, if you do happen to memorize it, is x equals the negative value of b plus or minus the square root of b squared minus 4ac all over 2 times a. So the quadratic formula is basically used to solve a quadratic equation for the unknown, in this case x. And sometimes we end up with 2 answers because of the whole plus and minus bit in the middle there. So we need to solve the equation for x. And why do we use this instead of completing the square method? Well, it's on reference sheet. So we have it available to use all the time. And second of all, it's actually much easier to use than completing the square. And again, completing the square I do after quadratic formula, again, because quadratic formula and factoring follow the same format, whereas completing the square, the format is a little bit different. So when it comes to factoring, straightforward factoring, breaking up a trinomial into 2 binomials, or using the quadratic formula, my equation has to be in the setup ax squared plus bx plus c equals 0. So that format, that setup is a must in order to use our quadratic formula. So we need our equation equal to 0. We need to identify the values of a, b, and c, where a, b, and c, again, are just 3 numbers that happen to be part of the equation. So moving onward to actually solving problems using the quadratic formula. Again, simplest radical form whenever possible. Here we are told in our first problem we need to solve for x. We have negative 3x squared equals 8x minus 12. So in this case, we don't really, as long as our equation equals 0, we're fine. So it doesn't really matter if it's x squared plus x plus a number equals 0 or 0 equals something. As long as we have equals 0 someplace, we're good. So what we need to do is we need to get this equation first and foremost equal to 0. So what I'm going to do here is I'm actually going to move the 3x squared over. The reason I'm doing that is because it's only 1 item and it'll bring it over to the side with 2 items. So first thing I'll do is move the 3x squared over. In our problem, it's minus. So to move it, we have to do the opposite. We're going to add 3x squared. And I cannot add 3x squared to 8x or 12. So what happens here is 3x squareds cancel out on the one side, and it leaves me with 0 equals. And that's the important part. We are now equal to 0. And we have 3x squared plus 8x minus 12. And the reason I put the 3x squared out front is because we like it being in standard form. X squared being the highest exponent comes first, so 3x squared. And then 8x would be next. There's no sign, so we can say it's a plus 8x minus 12. Now what we need to do in order to use the quadratic formula is identify the values of a, b, and c. So a, b, and c, if we go right down the line, a would be 3, b is 8, c is negative 12. And again, we can do that because the format for quadratic formula is ax squared plus bx plus c. So quadratic equation, ax squared bx plus c. What we'll do now is we will set up the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And everywhere there's an a, b, and c, I'm going to replace with its respective letter. So negative value of b, so negative value of 8 plus or minus the square root of 8 squared minus 4 times 3 times c, negative 12. And that's all over 2 times a, 2 times 3. So we're going to go through and we're going to simplify everything that we can. So we have negative value of 8, so that's just negative 8. Plus or minus the square root. And we can do everything underneath the square root symbol. So we have, in parentheses, we have 8 squared minus 4 times 3 times negative 12. And we get 208 all over 2 times 3, which happens to be 6. So what I need to do now is I need to simplify square root of 208. So I'm basically going to go through and I'm going to divide, I'll try 4, which gives me 52. If I divide by 4 again, gives me 13. So let's see, can I do 208 divided by 16? Yeah, gives me 13. So here what we have is negative 8 plus or minus the square root of 16 times 13 over 6. And again, the reason I did that is because I can break down 208 into 16 times 13. So now what I can do is I can take the square root of 16. 16 is a perfect square. So we have negative 8 plus or minus, and then the square root of 16 is 4 times the square root of 13 all over 6. So the last thing I want to do, because I cannot add 4 root 13 to negative 8, I have to leave it as is. So what I'm going to do is I'm going to simplify this as much as I can. So our whole numbers that we're dealing with, we have 8, we have 4 up top, and we have 6 on the bottom. So if I think about it, I can divide all 3 of these by 2. So negative 8 divided by 2 gives me negative 4 plus or minus, and then if I divide 4 by 2, I get 2 root 13 over 3. So all I did was divide our 3 whole numbers in our problem, 8, 4, and 6, by 2, and we end up with a simplified form of negative 4 plus and minus 2 root 13 over 3. And we get to do the same thing for number 2. Solve for x. We have 3x squared plus 5x minus 12 equals 0. So first things first, is our problem in the correct format? And the answer is yes. It is in standard form, highest exponent to lowest. We are equal to 0. So all I have to do here is state the values for a, b, and c. So a is going to be 3, b is 5, c is negative 12. So we're going to use the quadratic formula here on this side here as well. So x equals the negative value of b, which in our case is 5, plus or minus the square root of 5 squared minus 4 times 3 times negative 12 all over 2 times 3. Then we go through and simplify. Negative value of 5 is just negative 5, plus or minus. And then we'll do everything underneath the square root in our calculator. So in parentheses, 5 squared minus 4 times 3 times negative 12. Gives me 169. So we have plus or minus the square root of 169 all over 2 times 3, which is 6. So I'm going to try taking the square root of 169, see if I get a nice number, which I do. So the square root of 169 is 13. So we end up with equals negative 5 plus or minus 13 over 6. Because now what we have is straightforward addition and subtraction of whole numbers up top, I'm going to split it up. So one fraction is going to be negative 5 plus 13 over 6, and the other one is going to be negative 5 minus 13 over 6. So negative 5 plus 13 gives me 8. And we divide that by 6. Gives me a nice fraction, so we turn it back into a fraction. Gives me 4/3. So there's one answer. And then we're going to do the same thing with the other fraction. We have negative 5 minus 13. Gives me negative 18. And we divide it by 6. Gives me negative 3. So there are my two answers using the quadratic formula in number 2 here. Third one here, we have the demon drop at Cedar Point. Take riders to the top of a tower, drops them 60 feet. And the equation that we are given for the ride is this one here. H equals negative 16t squared plus 64t plus 60, where h is height and t is time. How many seconds does it take for a rider to take ground level? Well, ground level is a height of 0. So this means 0 equals negative 16t squared plus 64t plus 60. So we can use the quadratic formula here because we are equal to 0 and our equation is in standard form. So we just state what a, b, and c are, which in this case is negative 16, 64, and 60. So we're going to use that quadratic formula and plug in everything where it goes. So negative value of b, so negative 64, plus or minus the square root of 64 squared minus 4 times negative 16 times 60 all over 2 times negative 16. And we go through and we simplify this. So negative value of 64 is just negative 64. Plus or minus the square root. And again, we're just going to plug everything under the square root symbol into the calculator to get a nice answer. So we have 64 squared minus 4 times negative 16 times 60. Gives me 7,936. And that is all over 2 times negative 16. Which gives me negative 32. So now what we want to do is we want to see what the actual value is. So it says about how many seconds. So unlike before where we left it as a fraction when I didn't really have a nice set thing, we want to know specifically the number of times. And this could include decimals. So I'm actually going to solve for each value here. So once we're to this point, I actually have two possible values. We have x equals negative 64 plus the square root of 7,936 divided by negative 32. And we also have x equals negative 64 minus the square root of 7,936 divided by negative 32. So what I'm going to do is I'm just going to do the top part first, and then I'm going to divide by the bottom. So we have negative 64 plus the square root of 7936 gives me this decimal, and we're going to divide by negative 32, which gives us a decimal form, again dealing with time, so hundredths, so negative 0.78 seconds. And then we'll do it for the same thing over here. We have negative 64 minus the square root of 7936, and we divide it by negative 32. Gives us a rounded time of 4.78 seconds. Now, because we are dealing specifically with time, our answer has to make sense in the realm of reality. So if my one answer is negative 0.78 seconds, that's not possible. We've gone back in time, so this one can't work. So that one is a no-go because we cannot have negative time. Our second answer, 4.78 seconds, that does make sense. The ride is over in just under 5 seconds. So that is using our brains a little bit to figure out which answer possibly makes sense. And sometimes we're given that choice. And in this case, we had to eliminate one answer. So sometimes we get a situation where we will leave it as a improper fraction here, negative 4 plus and minus 2 root 13 root 3. Sometimes we get nice answers, like 4/3 and negative 3. And other times, depending on the situation given in our problem, we may have to eliminate one of the answers we get because it does not make sense.